Viruses. Where did they come from? There are many theories. Some claim they appeared in the prebiotic soup environment, which gave birth to life on Earth. Others prefer they arose from fragments of genetic material that was released from various cells. One thing is for certain, they are an integral part of life, although they are not living organisms themselves. Sometimes these ruthless parasites led people to wealth, as in the 17th century in the Netherlands, when bulbs infected with the tulip-breaking virus could reach astronomical prices. At other times, they brought epidemics and death. However, like every work of nature and evolution, they play an important role in life. And although sometimes they are a threat to us, they are necessary for maintaining the balance of our ecosystem. Some, such as bacteriophages, attack harmful bacteria, while others support us in the fight against cancer. And even some are useful for nature's bacteria. For many living organisms, viruses are completely harmless, and most of them pose no real threat to us. We are no stranger to them, and we will find them everywhere, in water, air, soil, on the surface of objects that surround us. One drop of water could contain millions of them, and there are billions of them in the human body, though they rarely pose a threat to our health. However, there are exceptions in the form of pathogenic viruses. These connect to or penetrate the membrane of a living cell and insert their genome to start the replication process. The genome is actually an RNA or DNA nucleic acid that contains the information needed for the virus to multiply in the body. Although viruses may seem and work in a similar way, they are radically different. Let's take the flu virus. It has many strains, and the virus itself often mutates, so creating a 100% effective vaccine is extremely difficult. In addition, there are 3 types of flu viruses: A, B, and the basically harmless C. In turn, COVID-19, often compared to the flu, is actually an infectious disease caused by a coronavirus, which means that there is not much in common with the flu, except for the symptoms. However, coronaviruses that attack the human body are not new. The first one was discovered in 1962, though they did not attract much interest from researchers because they did not pose a major threat to humans, as they only caused symptoms of a slight cold. This changed after the outbreak of a severely lethal SARS in 2002 and MERS 10 years later. Now the new threat is a new type of SARS-type coronavirus, SARS-CoV-2. Is it a mutation of the already known coronavirus, as evidenced by the high infectivity and lower mortality rate than with SARS and MERS viruses, or a chimeric SHC014 type coronavirus, like the one created in 2015 that escaped from a scientific lab? Or maybe it is a completely new pathogen. Suffice it to say that it behaves slightly differently than its predecessors. A significant proportion of infections are asymptomatic. In the case of the SARS-CoV virus from 2002, the symptoms were quite clear, so it was easier to isolate the patients. Interestingly, it was quickly discovered that in the bodies of people engaged in the trade of live animals at marketplaces in China, antibodies neutralizing this virus were present, although these people never, in theory, contracted the disease. It was certain, though, that animal-derived viruses began to spread to humans. In the case of SARS-CoV, the source of the virus turned out to be bats. And in the case of MERS, one-humped camels. Also, COVID-19, or rather SARS-CoV-2, probably comes from bats, and its appearance was not a surprise to many. Researchers have long suspected that a similar virus will return, and it is likely that the SARS epidemic of 2002 was not the first time the virus had migrated to our species, since appropriate antibodies had already been found in serum samples taken prior to its epidemic. This indicates that this virus has already attacked people before, but most likely it was not yet well adapted to multiply in our cells. However, everything suggests that SARS-CoV-2 has already adapted perfectly. There are several lessons to be learned here. Human interference in the natural environment, animal testing, or contact with non-farm animals can cause viruses basically harmless to them to infect humans. At the same time, the history of the SARS-CoV virus quite clearly suggests that the COVID-19 epidemic is not the last of its kind. But let's also remember one thing. With each mutation, the virus usually becomes more infectious, but also less dangerous to our health. After all, no parasite wants to kill its host. Meanwhile, the new epidemic is just beginning.